Let's talk about uneven cooling in your mini fridge. The food in the back freezes, food in the front's getting way too warm. There's really no plug-and-play solution on the market other than these little things. Reports say the two D-cell batteries last about a month, so if at any time this project seems intimidating, I'd recommend just going along this route with the addition of some rechargeable batteries. But for now, let's dig into the battery-free, hardwired solution. I'll give you a good overview of the procedure to add a circulation fan to your fridge, but keep in mind yours may be set up differently. Specifically, I'm modifying a Frigidaire FFP-S 3133UM, but chances are if your mini fridge has an internal light and was manufactured after the turn of the millennium, it's probably going to be very, very similar. Here's what we'll need. A 12-volt computer fan. Here's the one that I used. A properly size-matched grill for the fan. A few feet of stranded copper wire, somewhere between 20 and 28 gauge thickness. A standard USB wall charger, and of course some general electrical knowledge, tools, and hopefully common sense. So, with your general electrical knowledge, you know your fridge runs on 120 volts AC, you also know your USB power brick converts 120 volts AC to 5 volts DC, and finally, you know the computer fan is rated for 12 volts DC. You can probably visualize where this is going already, so let's jump right into the wiring. One of the main challenges of this is finding where you want to draw your 120 volt AC power from. Here's the wiring diagram for this specific fridge, which is probably identical to countless others on the market. And luckily this fridge, and any fridge with an internal light, is going to have both the hot and neutral wires accessible from inside the fridge. Otherwise, you'll have to drill a hole to run the wires out the back and down to the compressor area. Inside our light and thermostat housing, we're only going to find the hot side of the AC circuit. The neutral feed is tied in behind the door switch here. Very conveniently, this door switch is a single pole dual throw switch. Don't worry too much about the terminology, it just means when the door is open, the switch directs the neutral feed coming in here through the common terminal to the interior fridge light, going out through here, the normally closed terminal. This is perfect for our fan project because it's going to turn on the fan when the door is closed. The power will flow through the normally open terminal, but it will also disable the fan when the door is open. You don't want to blow your cold air out the door, right? And luckily my spare USB charger was incredibly easy to disassemble, and I could actually fit the whole circuitry inside the thermostat housing. I ran my neutral wire from the door switch, the normally open terminal in the center, to one of the 120 volt charging input ports on the circuit board. I didn't get any close-up footage at all of the wiring of the USB charger from the 120 volts to the 5 volts DC. Luckily, there are a ton of teardown videos on YouTube here. You'll be able to find one, some general knowledge, and you'll figure it out. Now, inside the thermostat assembly, you'll have 3 wires going to it, plus a ground. You have the hot coming in, that's on terminal H, the line feeding back from the light to complete the circuit, and the output C going to the compressor. So you'll want to pull your hot off of this terminal H, which on this thermostat assembly is the black wire on the back. You can see the H right there. Or if you want the fan to only run when the door is closed and the compressor's running, you could tie in to terminal C right here. Again, I forgot to get close-ups of my specific charger, which looks like this, and apparently is dangerous, but here is a screenshot of what the inside of my specific charger looked like. Again, depending on which charger you have, the inside guts are going to vary. And once you have your 120 volt AC power finished and soldered onto your 5 volt DC charging brick, it's time to focus on the DC side of things. So you'll have your USB output here on the other end, and you'll just solder on some extension wires to the DC positive and negative outputs there. That's what's going to run your fan. Now, it's a good idea to mark which is positive and negative, as most modern computer fans won't run with the polarity reversed. Then you can grab your multimeter or just wire it up to the fan to test it out. Now, it's worth noting that most 12 volt computer fans won't have any issue running on 5 volts. Yes, it's going to run much slower, but also much quieter. And the truth of the matter is, it doesn't take much to successfully circulate all the air in such a small space. There are variable voltage boosters out there if you'd like to control your fan speed. They're pretty affordable. I'll link to those down below. And also know that a small percentage of 12 volt fans will require more than 5 volts to start spinning. It's rare, but it could happen. If that's the case, you'll either need a different fan or the aforementioned voltage booster. Anyway, my setup is all done with the wiring. It powers it when the door is closed and cuts power when the door is open. Next is probably the most scary part, which is mounting the fan. You'll want some long, sharp screws and also some rubber or foam spacers to put between the fan and the fridge. You could even cut up some $1 foam flip-flops. Ideally, you'll want to mount the fan against the evaporator grid. That's the part that's getting cold inside the fridge, and inside some fridges, it's really easy to identify where the refrigerant is flowing and where it's safe and unsafe to drill the holes for fan mounting. However, in this fridge, the evaporator lines are hidden behind the white plastic shell. Here's a quick snippet of my video doing a full fridge teardown, and that shows all the locations of those refrigerant lines. Now, for obvious reasons, you definitely do not want to hit one of these lines. What I did to try to figure out the location of the lines was use a standard stud finder, and it was picking up these 3 spots here, so I marked those off. Also, I turned on the fridge and brought out my infrared temperature gun just to point at the back of the fridge, see if I could mark out and find where it was getting colder than the rest. That would be exactly where those evaporator lines are. But really, the temperature gun didn't help that much. But I went with my 3 spots that I found with the stud finder and promptly hit one of my lines, leaking out all my refrigerant.
Sound of leaking freon.
Now, the repair video is a roller coaster of refrigeration no-nos, explosion avoidance, refrigerant comparisons, and finally settling for slightly lower efficiencies in the name of safety. But anyhow, the fridge is working once again. I mounted the fan only to realize the retired solar charge controller fan is garbage and loves making loud noises once it gets cold. Very frosty in there, super cold. Definitely not going to have that mounted right next to my bed. So I upgraded to the 120mm fan linked below and had to re-drill more holes and hope to avoid the refrigerant lines, which luckily I did, and then I buttoned it all up. So here it is. Overall, I'm extremely happy with it. It's been running for nearly half a year now without any issue, and I 100% recommend this upgrade, but also wholeheartedly hope you're more careful, or at least more lucky than I was in my endeavors.
That's the sound of leaking freon.
So that's it for this video, guys and girls. Avoid hitting those refrigerant lines, don't get electrocuted, and I'll see you next time.